Hello class, it's Ms. Augustine. Today we're going to do an average atomic mass calculation. We're going to calculate the average atomic mass of tungsten, and typically in such a calculation you're given a table like this and you're going to be given data for the various isotopes, and you'll notice that tungsten has 5 isotopes. Remember that isotopes are atoms of the same element with different numbers of neutrons, which results in them having a different mass. And the second column here is showing the actual relative atomic mass. And remember that with mass number, which is what's in the first column, it's rounded to the nearest whole number. So you'll see 179.94 and change becomes 180. Then you're given the percent abundance. And in order to do the calculation that we need today, we're going to have to take our percent abundance for each of the isotopes and start by converting them to relative abundance. To convert percent to relative abundance, you're going to divide by 100. So here I'll just fill these in. The first one's going to be 0.0013. The second one is going to be 0.2630. The third one is going to be 0.1430, and so on. And finally, now, to do our calculation, we're going to have to multiply the actual relative atomic mass for each isotope by its relative abundance. And the analogy here is when you're calculating, for instance, your grade point average, they take each course that you're taking and they multiply that grade by its number of credits, which is its weight in calculating your average. And that then allows you to do a weighted average where you'll add all of those up. So let's go to our next slide and we'll do our calculation. So here you'll see I have the same data table, but now down here at the bottom I've gone ahead and I've done the calculations. So in each case I'm multiplying for a particular isotope its actual mass times its relative abundance that we got from the percent abundance, and then we're going to take that number and we're going to plug it into our data table. So I'm going to go ahead, and these calculations are a wee bit tedious, I will admit, but they are not difficult. So again, very carefully cutting and pasting if it lets me. It really wants to get that little extra space. And finally, the last one. So now that we have all of these numbers, we have to come up here and do a total. And after tediously plugging them all into my calculator, I end up with the number 183.848,908,075, which seems like a lot of numbers. However, this is a weighted average, and so we are going to keep all of the digits in here for average atomic mass. And the last thing we need to do is look in our periodic table and compare the actual value for tungsten to the value that we calculated to make sure we're not really far off. So I looked in my periodic table and I found that tungsten's actual mass is 183.84 AMUs, and comparing that to the number that we achieved is correct. So that, in a nutshell, is how to do an average atomic mass calculation. Hope this helped.